Hello! In this video, I will try to solve some problems, items 1 to 10 of the MIT Integration B 2013 Elimination Space. So, just as a background, the MIT Integration B is a yearly tradition during MIT's Independent Activities period, which is held every January and run by MIT math graduate students. The B is open to all MIT students, although most who participate are undergraduates. This is taken from MIT Integration B website. And essentially, an Integration B is sort of a quiz bee where you only solve definite and indefinite integrals. So it typically has 2 or 3 phases. The first of which is the eliminations phase, where you are given a set of questions and then you try to solve that within a specific time limit. The faster you can solve the problems, and the more problems you can solve, the higher chances of you moving on to the next round. So for this video, I will be trying to solve the problems in the elimination phase of the MIT Integration B in 2013. So these are the first 10 problems. Some are definite, some are indefinite. 4 of them, or 5 of them are definite, and the rest are indefinite. Some are quite easy, some are maybe not. Anyway, let's try to solve. For the first item, we solve the integral of log of x squared minus 2 log of 2x dx. So it's the integral of log x squared minus 2 log 2x dx. You might want to be happy. You might want to simplify this first, like bring down this exponent and then split this one, log 2 plus log x, but an easier way to go about this is to combine them. So instead of splitting this, what I can do, or what we can do, is to raise this 2x to the power of 2. So this becomes 2x squared. And the whole thing becomes 4x squared. By the property of logarithms again, this becomes log of x squared over 4x squared, since it's a minus here. So we are left with the integral of log of x squared over 4x squared, which simplifies to the log of 1/4, which is just a constant, and it's also equal to negative log of 4 dx. So this becomes negative log of 4 times x plus c. This should be solvable in under maybe 15 seconds. Next, for the next question, we are asked to solve a definite integral, negative 1 to 3 of e to the absolute value of x dx. So we should split x, since its definition is not the same over the interval negative 1 to 3. So it becomes x is equal to positive x if x between 0 and 3, and equal to negative x if x is between negative 1 and 0. So this integral here is rewritten as 0 e to negative x dx plus 0 to 3 e to the x dx. Now this one, we can just let u is equal to negative x, and then we'll have something like e to the u. So this becomes e to the u times du is equal to negative dx. So I can put out the negative. This is the du. At x equals negative 1, u is equal to positive 1. And then at x equals 0, this is still 0. So essentially, this is equal to, because there's a negative here, we can just switch the limits, 0 to 1, e to the u du, which gives us e to the u evaluated from 0 to 1, and it's equal to e minus e to the 0, which is 1. So that's the first part. The second half is the integral of e to the x dx, which is just e to the x. So evaluate from 0 to 3. So this is e cubed minus e to the 0, so e to the 3 minus 1. So overall, the total is e to the 3 minus 1 plus e minus 1, which is e to the 3 plus e minus 2. Also quite simple, I guess. Next, we're looking for the integral of log x cos x minus sine x over the square of the log. In MIT and in some other institutions, especially in physics, I think, the function log x is the natural logarithm. So in other notation, this is also equivalent to ln of x. So I'll just rewrite that since I'm more comfortable with ln x. Probably you're more comfortable with it as well. Over ln squared x dx. Now whenever you see something squared in the denominator and a difference in the numerator, it should give you a hint that its antiderivative is of the form f over g. It is because the derivative of f over g is low d high minus high d low over low. So this one, it's just quite obvious that g is ln x. So the antiderivative of this is ln x, which corresponds to this. So the other partner of that is something whose derivative is cosine x, which is sine x. Then plus c. So the answer must be sine x over ln x plus c. Just to check, we take the derivative of this term, low d high minus high d low over low. That's it. So the antiderivative is sine x over ln x plus c. Next, number 4. We are asked to find the integral of 1 to 11. It is again definite integral. X cubed minus 3x squared plus 3x minus 1 dx. If you're quite familiar, this is just x minus 1 cubed. How does that help? Well, it helps you not to expand, to evaluate or to integrate each of the terms individually. So this quite simplifies the process by a lot. So that is x minus 1 cubed. If we use a substitution, u is equal to x minus 1, we have du is equal to dx. So this should be 1 to 11. And so this one becomes u cubed du, and then at x equals 1, u equals 1 minus 1, so 0. At x equals 11, u is equal to 11 minus 1, so that's 10. Then integrating this, power rule, e to the 4 over 4, 0 to 10 is equal to 10 to the 4th over 4 minus 0. And this is 10 to the 4th, so that's 10,000 over 4. That gives you 25. So the answer is 25. Next, number 5. 0 to 2 of 12 minus 3x squared dx. Seeing a quadratic term here, you might be tempted to use trigonometric substitution. But before that, let's simplify the equation first, or the integrand first. So take out the 3 because 3 is a common factor. So that becomes 0 to 2 of square root of 3 times square root of 4 minus x squared. So I can factor out this square root of 3, and we are left with 0 to 2 of 4 minus x squared dx. Again, you might want to use trigonometric substitution right away, but if I were you, I won't. Because if you notice, this thing here, we just let it equal to y. Y is equal to 4 minus x squared. If we square both sides, this becomes y squared is equal to 4 minus x squared. So that's x squared plus y squared is equal to 4, which is the equation of the circle centered at the origin and with radius 2. So this integrand tells you that you are looking for the area under this circle from 0 to 2, which is this part. And so this integral here is equal to the area of this quarter circle. So being a quarter circle, its area is equal to 1/4 of the area of the circle, which is pi times r, which is 2 squared. This is 4 pi, so 1/4 times 4 pi, that's just pi. So this whole thing here becomes pi. So the answer is pi square root of 3. If you don't believe me, you can use a substitution x is equal to 2 sine theta. You'll get the same answer. Next, number 6. It's 0 to 6 of x plus x minus 3 to the 7 plus sine x minus 3 dx. Individually, these terms are easy to evaluate, but I don't want you to do that because there's something pretty about this problem. Let's use a substitution u is equal to x minus 3, so that x is equal to u plus 3 and du is equal to dx. At x equals 0, you'll get u is equal to negative 3, and then at x equals 6, you'll get positive 3. That's why this is pretty. Because you have something like negative a to positive a, which if the integrand is even, if odd, then that simplifies to 0. So that's what we will hunt for now. So x becomes u plus 3. This becomes u to the 7, and this becomes sine u du. This is odd because sine of negative u is equal to negative sine u. This is also odd because the exponent is odd. This is odd. So we are only left with this term, which is even function. All the rest becomes 0. It's because of this property. Negative a to positive a of f of x dx is equal to 0 if f of negative x is equal to negative of f of x. So this whole integral here is equal to negative 3 to 3 of 3 du, which is just 3u evaluated from negative 3 to 3. So that's 3 times 3 minus negative 3 is equal to 18. So this is 6. You can also just evaluate this, but that's not suggested. Next, number 7. We are asked to find the integral of sine x square root of 1 plus tangent squared x dx. This term here is equal to secant squared. So the square root of secant squared is just secant. So sine x times secant x dx. This is 1 over cos x. So this becomes sine x over cos x dx. If we let u is equal to cos x, du is equal to negative sine x dx. So this integral becomes negative of 1 over u du, which is equal to ln of u, absolute value of that du. Plus c. So this is equal to negative ln of u is cosine x, so this is absolute value of cosine x plus c. Alternatively, you can write this as ln of cosine x to the negative 1 plus c, which is cosine to the negative 1 is secant x. So you can also write it this way. Both should be accepted. Next, number 8. So we are looking for the integral of x to the 5th minus x cubed plus x squared minus 1 over x to the 4th minus x cubed plus x minus 1 dx. You should get the feel that there's something common between the numerator and the denominator. Let's try to factor them. For the numerator, we can factor out x cubed for the first term plus x squared minus 1. So we have this and this common. We can factor that out. X cubed plus 1. Hey. In the denominator, we have x to the 4th. Factor x cubed. So x cubed times x minus 1 plus x minus 1 is equal to, factor out x minus 1 times x cubed plus 1. Hey, this is common. So the integral becomes x squared minus 1 times x cubed plus 1, x minus 1, x cubed plus 1 dx. This cancels out. This can be factored out, x minus 1 times x plus 1. So the x minus 1 should cancel out as well, leaving us only the integral of x plus 1. So from this complicated expression, it becomes as simple as this, which we can easily integrate as, by power rule, x squared over 2 plus x plus c. Done. Next. Second to the last problem, number 9. We are looking for the integral of ln x, that's log x dx 0 to 1. This is just again ln x dx 0 to 1. You can use IBP for this one. So let u is equal to ln x, dv is equal to dx, du is equal to dx over x. This gives you v is equal to x. So the integral is integral of ln x dx. I will just consider first the indefinite integral. So uv, so that's x ln x minus v du, integral of x times dx over x. This cancels out. So this becomes integral of dx, which is just x. I'll just omit the plus c. So essentially, the integral of ln x dx is equal to x ln x minus x. So if we evaluate this from 0 to 1, this just becomes 0 to 1, and it's equal to 1 times ln 1 minus 1 minus 0 times ln 0 minus 0. This should give you, this is ln 1 is 0, so 1 times 0 minus 1 is equal to negative 1, and then this one is 0, 0. This one is a bit tricky. We actually have to use L'Hopital's rule for this one, but I leave that up to you, and the value of this is just 0. So essentially that's negative 1 minus 0, it's negative 1. If you have troubles evaluating this using L'Hopital's rule, let me know in the comments. I can solve it for you, of course. Also, just a minor tip, or maybe a major tip, if you are integrating ln x, the result is always x times ln x minus 1. That's a shortcut. It's quite helpful if you memorize that. Next, the final item for this video will be the integral of 1 over 1 minus e to the negative x dx. I'll just simplify this first. So this is 1 over e to the x minus 1 over e to the x dx. I'll just put that in the numerator. This becomes e to the x over e to the x minus 1 dx. If we let u is equal to the e to the x minus 1, du is equal to e to the x dx. This thing here is that thing combined. So we are left with du over u, which is ln of absolute value of u plus c. With the u being e to the x minus 1, that's just ln of absolute value of e to the x minus 1 plus c. There you go. So we've solved 10 items, and I think relative to the other problems, they are quite easy, especially if you look at the next problems in this set. So for this first 10 items, you should be able to solve this in under 10 minutes. Because the test is good for only 20 minutes and it's 25 items. So if you intend to join Integration Quiz B in the future, you must be able to solve this in less than 10 minutes. And that's it for this video. Stay tuned for the next part of this series, which is the items 11 to 25. See ya!